Microsoft Research built a machine with exactly one job: rewriting the instruction files we hand to AI agents. It got thousands of scored attempts, unlimited patience, no human anywhere in the loop. So what did the winning file look like when it was done? About 920 tokens, 1 to 4 accepted edits. Nearly everything the optimizer proposed got thrown out, and that near-empty file still raised a 6 benchmark average by 23.5 points. Which means the real question isn't how a machine writes instructions. It's why the machine keeps saying no. Here's the headline number. Running with GPT 5.5 inches direct chat. This system, it's called SkillOpt, pushed a 6 benchmark average from 58.8 up to 82.3. That's a 23.5 point jump. And the only thing that changed was a text file. The model's weights never moved. And the file that did it? Median size, roughly 920 tokens, shaped by just 1 to 4 accepted edits. If you've ever written a system prompt, a Claude.md, or a skill file, you know how weird that sounds. So by the end of this video, you'll know exactly how the loop works, what that 5.2 for 5.2 benchmark sweep actually proves, and what it means for the instruction files you're writing right now. Okay, so what is SkillOpt? It's an open source project from a Microsoft research team, and the core idea is honestly kind of elegant. Take a natural language skill document, just a plain markdown file of instructions, and treat it as the trainable state of a frozen model. You run the loop, and what comes out is a deployable artifact called best_skill.md, ready to hand straight to an agent. The paper behind it, SkillOpt, Executive Strategy for Self-Evolving Agent Skills, was submitted to arXiv on May 22, 2026, and it's already made the jump to mainstream tech press. VentureBeat framed it as an open source tool that automatically upgrades AI agent skills without modifying model weights. Which is accurate. But it buries the interesting part. The interesting part is how that upgrading actually happens. Mechanically, there are 2 roles. First, there's an optimizer model separate from the agent that's actually doing the work. It watches scored rollouts, complete runs of the agent trying real tasks, each one with a grade attached. And from those rollouts, it proposes bounded edits to one single skill document. Add a line, delete a line, replace a line. That's the entire vocabulary. Then comes the part that makes the whole system work. The gatekeeper. Every proposed edit gets tested against a held-out validation set, a separate set of tasks the proposals weren't derived from. And the acceptance rule is brutal. An edit gets in only if it strictly improves the held-out validation score. Not reads better. Not seems clearer. Measurably better on unseen tasks, or it's rejected. Even a tie is a rejection. Okay. But does it actually work, or is this one cherry-picked benchmark? The team evaluated 52 configurations, combinations of model, benchmark, and harness, spanning 6 benchmarks, 7 target models, and 3 execution harnesses. And SkillOpt came out best or tied best on all 52. 52 for 52. The single biggest jump was SpreadsheetBench, where scores went from 41.8 to 80.7, a 39-point gain from a text file. And it wasn't just beating a no-skill baseline either. Across those 52 configurations, it beat prior text optimization and skill evolution methods like TextGrad and EvoSkill. Now here's the part I actually want you to sit with. This loop can propose as many edits as it wants. Full optimization runs. Unlimited rewrites. And in the final skill files, only 1 to 4 edits survived. The overwhelming majority of what the optimizer proposed failed the held-out test and got thrown away. And here's my read on it. This is analysis, not something the paper claims. That's the exact inverse of how humans write these files. When we write a system prompt or a skill doc, we accumulate. Something breaks, add a rule. An edge case shows up, add a caveat. Every line sounds plausible, every example sounds helpful, and nothing ever has to prove it helps, so nothing ever gets deleted. SkillOpt flips that. Rejection is the engine of quality. The breakthrough isn't a machine that writes better instructions. It's a machine that refuses almost everything. And that should sting a little. Nearly everyone building with agents writes these files by hand, and the default instinct is always to add. If a frozen model plus a 920 token machine-vetted file can post double-digit gains, then every line in your file that hasn't earned its place is a candidate for the same rejection. Now, there's an obvious objection here. If the winning files are that small, maybe they're just overfitted tricks, magic words that happen to work for one specific setup. The optimized skills transfer. They hold up across model scales and across different agent harnesses. Same file, different model still helps. And again, calling this what it is, analysis. That transferability is the tell. Model-specific prompt hacks don't usually survive a change of model. Lines that do survive the move are more likely encoding genuine task knowledge, how the task actually works, not how to tickle one particular model. And that's why a frozen model plus a portable text file can behave like an upgrade. And none of this is trapped in a paper. SkillOpt is MIT licensed, and one command away, pip install SkillOpt with support for multiple model backends: OpenAI, Azure, Claude, Qwen, Minimax. It's moving fast, too. The V02 release landed on July 2, 2026, 1 week ago, and added SkillOpt Sleep, an offline self-evolution engine with experience replay. The repo's sitting at roughly 11.9 thousand stars. But even if you never install it, here's the takeaway, and I'm labeling this as my interpretation. Treat your own agent instructions the way SkillOpt does. Every line should have to earn its place against a held-out test, and deletion counts as an edit, maybe the most valuable one. So, back to where we started. 920 tokens, 1 to 4 accepted edits. At the top of this video, that was just a strange stat. Now you can read it for what it is. The fingerprint of a gate that killed everything that could improve its worth. That near-empty file isn't minimalism as a matter of taste. It's what discipline looks like when a validation score is the one enforcing it. So here's the one idea to carry out of this video. Earn every line. If you want to go deeper, the SkillOpt GitHub repo and project page are linked below. Read the paper, run the loop on your own skill files, and tell me in the comments what survived. And if this changed how you think about your prompts, subscribe. This is exactly the kind of open source AI work Neural Stack is here to break down.